Hi, in this video, I will be showing you problem number 5 of chapter 13, section 3. Find the length of the curve r of t, which is equal to 1i plus t square j plus t cube k in the interval t lying from 0 through 1. So here, the length of the curve formula is required. So how do you find the length of the space curve given by a vector function r of t? If r of t is f of t, g of t, h of t in the component form, where f of t, g of t, h of t are real valued functions and t lies from a through b, and the curve is traversed exactly once as t increases from a to b, then the length is given by L equal to integral a to b absolute r of t dt. This is a concept from your calculus 2 class, which is given by integral a to b square root of the derivative of the first component square plus derivative of the second component square plus derivative of the third component square from r of t. So it is square root integral a to b square root of f prime t the whole square plus g prime t the whole square plus h prime t the whole square dt, because the variable of the integration is t. So we are going to use this formula. So if we are given r of t in the vector form, so here f of t is 1, g of t is t square, and h of t is t cube. We are going to take the derivative of r of t, and then we are going to use this integral. So here the t value runs from 0 to 1, so a equal to 0, b equal to 1, and r prime t is derivative of 1, which is 0 I plus 2j plus 3t square k. So from here, r of t, you are taking the derivative of each component. Then we are going to find out absolute r prime t, which is square root of x component square plus y component square plus z component square from r prime t, which is 4t square plus 9t to the power 4 within the radical. So if you take the t square as a common factor inside the radical, you get that to be t square times 4 plus 9t square, everything within the radical. So if you take the t square out of the radical, so it is t times square root of 4 plus 9t square. That is absolute of r prime t, or the length of the vector r prime t. This is the one that goes as an integrand to find the length of the arc, length of the curve. So to find L, we have to integrate this function within the limits, in the limit 0 through 1. So here t is positive, that's why we are able to write square root of t square as t, because t runs from 0 through 1. So L is integral 0 through 1 t times square root of 4 plus 9t square dt. Obviously here we are going to use sub method. So anything inside the radical becomes u. So 4 plus 9t square is u. If you differentiate that, you get du equal to 18t dt. So 18t dt is du. And then also, because we are changing the limits of t to limits of u, we have to find out the new limits for u. So u is 4 plus 9t squared. The lower limit of t is 0. We have to get the corresponding u. Upper limit of t is 1, and we have to get the corresponding u value. So u becomes 4 and 13. With these values, and we have to compute the L. So it is integral 4 through 13 square root of u, and then you do t dt, just from here t dt. If we divide by 18, t dt becomes du over 18. Keep in mind, when you integrate, everything should be converted to the new variable. So that will be du over 18. So 1 over 18 can be brought out of the integral sign. So it is u to the power 3 halves over 3 halves between the limits 4 and 13. If you do the math here, it is 1 over 18 times 2 over 3. So this will become 1 over 9 times 3. That will be 1 over 27. Then it is upper limit 13 to the 3 halves minus 4 to the 3 halves. So that will become 13 square root of 13 minus 4 square root of 4. Inside the parenthesis and outside you have 1 over 27. If you simplify, it is 1 over 27, 13 square root of 13 minus 8. That is the length of the curve. So keep in mind here that the arc, the limits are given here. Otherwise, you have to make sure that the curve is traversed only once in the interval given. So in most of the problems in this section, we will be using a bunch of formulas. Go through my lecture videos on this section for concept verification. And then in the next problem, we will be finding the curvature. Hope this video helps.